So, hi everyone. This is my group. We are from group 15, and our company's name is Bubbly Methanol Production. So, I myself, Mira, Shadid, Izzati, and Jihan. So, these are my group members. And then, this is my process selection route, where in this design we are assigned to produce methanol by using natural gas. So, this is the first unit, desulfurization, pre-reformer, autothermal reformer, methanol synthesis, pressure swing absorption, evaporator scrubber, and distillation. So these are the units involved for the production of methanol. As in unit 1, like desulfurization, the purpose is to remove sulfur traces, which is hydrogen sulfide, from the feed process so that it does not settle down at the bottom of the tank and poison the feed, which will affect the whole process. So the efficiency is around 95%. So as we see in Excel, 0.38 of molar fluoride of uh, hydrogen sulfide is removed, so the balance is sent to the next stream. Next, my second unit is pre-reformer. This unit, the purpose is to methanate the higher hydrocarbon and methane. So these are the advantages of it, and these are the conversion. So the equations involved are methane plus water, carbon, and we will get carbon monoxide, hydrogen, and also carbon dioxide. As we see in Excel, 0.02 hydrogen sulfide, which is the whole hydrogen sulfide is being removed, and water is added, and for the ongoing stream, 474 mole per hour of fluoride is sent to the next stream. This is unit 3. Unit 3 is all about autothermal reformer, where oxygen is used to convert to syngas and to increase the oxygen intake. So basically, these are the assumptions. For autothermal, the molar fluoride that is sent to the next stream is 670 molar fluoride. This is the equation involved for unit 3, oxygen and what is added. For unit 4, methanol synthesis, the purpose of this unit is to convert syngas to methanol. These are the syngas, and these are the assumptions for this unit. The equation involved is this one: carbon monoxide, hydrogen, and oxygen is converted to methanol. For the calculation, 589 molar fluoride is sent to the next unit, where methanol production of 36.77 molar fluoride is obtained. So that is all from me. Thank you.
My name is Nurizati Binti Yusof and my matrix number is 191958. So, as we can see, after methanol synthesis is usually distillation. However, we added two units, which is pressure swing exhaustion and evaporator to. Okay. First of all, we added pressure swing absorption because we want to remove a higher concentration of carbon dioxide in the stream number 9. And then this pressure swing absorption is to reduce the amount of unwanted gas such as carbon dioxide so that we can increase the composition of our product. So the assumption that we made are 68.4% of carbon dioxide is separated from the stream to increase the mole fraction of methanol, and the balance of carbon monoxide enters the ongoing stream. Next, since in this pressure swing absorption, the molar flow rate of water is too high. So in order to decrease the amount of water in the stream, so we are going to use the evaporator, which is the liquid refrigerant is expanded in the evaporator, and the function of evaporator is to reduce the amount of water in the distillation column. So the assumption that we made are 68% of water is separated from the stream to increase the mole fraction of methanol, and the balance 2% of water enters the final stream. So evaporator is also called as boiler. So after we have done our calculation on the boiler, we can see that the molar fraction of water is decreased so that we can have a high composition of methanol. in distillation, okay, as we have seen from the evaporator, there are still a lot of impurities in this stream So therefore, we add scrubber because we want to separate the liquid and gas gases. We want to clean air, film gases, or other gases by protecting materials with solvent um, based on our journal, the gas temperature above the dew point causes condensation, and so it is also act as a condenser. So the assumption that we made, our ratio of water to carbon dioxide is 0.36 and the efficiency is 100%. So from this scrubber, we can separate the gas and the liquid into separate stream, in which this stream is going to distillation column. So the in distillation, the purpose of this distillation column is to separate mixture based on its volatilities and to have a better purification of methanol. In this distillation, we want to increase our purification of methanol and the saturation of methanol in for our methanol product. So it has a high quality. So we have a high quality methanol. So, in order to get this composition, we use the Rolle's law equation, which is we take the P saturation based on the temperature that have been that we have that have been searched. So, um, lastly, we can get the composition of this methanol product, which is 29.87 molar per hour for our methanol products. So this is all from us. Thank you.
Hi, my name is Muhammad Shadid, metric number 194192. This is rough costing estimation. We have given a feed 100 million metric ton and we might produce 541387.09 ton of methanol per year. Operating cost for raw materials, our raw materials is natural gas and our price is that 29.40 ringgit per ton. At product, our price of methanol, we chose China as our price as it is the least among the other four price of methanol. This is the methanol demand forecast. As you can see, it is in constant increase trend. This is amount predicted in 5 years or 10 years time at 2023. The amount reached 100 plus million megaton. At feed, the price of feed natural gas is 29.40 Indonesian ringgit per ton and our supply is Minin Gas Limited. Our quantity of feed consists of 96% of CH4, 1.8% C2H6, 1% N2, 0.5% CO2, 0.54% H2S, and the balance is inert gases. Our competitors for regional is Petronas Chemicals Group, Chemsins Sdn Bhd, and Proman Gesellschaft Fuel. Globally, we have Methanex and EcoFuel, and also Coogee Energy.
Hi, Assalamualaikum. My name is Nur Jahana Jalmita Azari, matrix number 192198. So I'm going to talk about sources. So this is the price index for natural gas supplier. For information, our supply is onion gas. So according to the graph, you can see that natural gas production is maintained over the year, but the natural gas price index always fluctuated over the year. So why we choose onion gas as supplier is because it excels in operational system. For information, this company use two systems in order to make a high quality of their product, which is molecular gate nitrogen rejection system, and the second is molecular gate carbon dioxide removal system. So the second reason is the reasonable price compared to other companies, and also the company is located at Peninsula Malaysia, thus reducing the transportation fees. So for the risk analysis, for the operational for the operational is like explosion and jet fire. For gas release rate, with this sake of failure, the release rate will drop to a fraction of peak initial value. So for humans, like illness, death, and for reputational, it's like loss of customer or employee confidence. For project going over budget, experiencing issues with product or services. For financial, like business failure, stock market fluctuation, and for natural, like natural disaster or diseases. So how much price of product is affected with price of it? As you can see, this is the current price. So if we calculate the ratio, price natural gas over price of methanol times 100%, we got 2.5%. So based on ratio given, if price natural gas increase, so our price of methanol also increase, which means RM 2,450 per ton. But if the price of natural gas decrease, so our price of methanol also decrease, which is RM 612 ringgit and 50 cent.
So this is cost analysis for our design. In order to obtain the cost price for natural gases, we need to times the total mass flow rate for natural gas by the price of natural gas, and then we get 2940,000 billion per year. And in order to get the selling price of methanol, we need to times the mass flow rate of methanol by the price of methanol per ton, and then we get 612,823,252 billion per year. And our catalyst, we use zinc oxide, activated carbon, nickel, and the prices 6,030, 4,422 and 48,240 ringgit respectively. And our profit of company, in order to obtain our profit, need to subtract our selling price by the cost price, and then we get 3,672,7,064 and 560 billion per year. In conclusion, for our design, our company will produce about 10,170,166.64 metric ton methanol per year by feeding 100 mega metric ton of natural gases per year. We have found that the profit that we will make is 6,612,823,252 billion per year, as the price ratio for feed composition is literally small compared to the price of methanol. At high price, only a small amount of methanol can be sold. Hence, we can compensate the investment that we make for operating processes through the profit. To make it up, our design that we are using to synthesize methanol from natural gases is feasible.
So for the last part is, for our recommendation is, first, the waste product of H2O can be sold to become other products for which are in high demand. This in turn will increase the revenue of our company, for which can be used for our operating process to cover the cost. So the second, the profit that were calculated were just an estimation, due to the price of equipment and electricity were not included. Further details required to obtain desirable accuracy of profit of our company. So that's all from our group. Thank you very much.